Section 5.6, Polynomial and Rational Inequalities. In this section, we will learn an algebraic technique to solve polynomial and rational inequalities. First, we're going to review how to solve a polynomial equation and inequality graphically. So we're given the function f of x equals x cubed plus 2x squared minus 3x. And here is its graph. If we want to solve the equation f of x equals 0, we want to find the x values on this graph where the y value equals 0. So we know f of x is our y value. Well, if the y values of 0 are 0, we know we're hitting the x-axis. So we can see we have 1, 2, 3 zeros. So the zeros of this function are the x values of -3, 0, and 1. Now, if we want to solve the inequality, f of x less than 0, we want to know where the y values of this graph are below 0, are less than 0. Well, we know on a graph the y values are less than 0 anywhere where the graph falls below the x-axis. So we want to look below the x-axis. So we can see here's a region below the x-axis and here's another region. So in interval notation, my first region goes from -∞ to -3. And I'm using a parenthesis on the -3 because there's no equals. This is a strict less than, no equals on it. And then my second region, I'll join it with the U symbol. My second region goes from 0 to 1. So I'll use my parentheses, 0, 1. So here's my solution to that inequality. Then my third one, f of x greater than or equal to 0, I want to know where my y values are greater than or equal to 0. So now I'm looking above the x-axis. So on my graph, I see I've got a region here and a region here. So in interval notation, I have a piece from -3 to 0, and now I'm using brackets because this inequality has the equals. It's greater than or equal to. And then I'll join that with my second piece, which goes from 1 to infinity. Again, bracket on the 1, comma, infinity. Now, if I go back up to the equation, I do know how to solve this equation algebraically. So let's review. If we want to solve f of x equals 0, I'll copy my function down here, x cubed plus 2x squared minus 3x equals 0. So if I didn't have the graph, I could algebraically solve this. We could easily factor, take out the x. Then we've got a quadratic which we can break down. X plus 3 and x minus 1. Then setting each of those factors equal to 0. I have x equals 0, x plus 3 equals 0, and x minus 1 equal to 0. And we can clearly see that these would give us our three solutions here. The two inequalities in this section, we're going to learn how to verify these and solve these algebraically. The technique we're going to use is called a sign chart, and it will allow us to identify regions where this graph falls below and above the x-axis, even if we didn't have the graph.